just to give you an idea how lucrative the EEPROM business was for Intel, in 1981, Intel was selling, my team was developing the 64K EEPROM, and we were selling those at $150 a piece, 64 kilobit, and people were standing in line. I mean, it was like 3 months delivery.
Yeah.
You just couldn't make it fast enough.
And EEPROM was making 105% of the profit of the company.
All right, thank you, Stefan.
Question. I have a question. You emphasized quartz window, but the big E product was the one-time program.
Yeah,
Okay, that should be mentioned.
that's correct. That's correct.
Go ahead, Eli.
All right, so so I was at Intel from 1979. Actually, Dov Froman heard about my work at Hughes, on thin dielectrics, and enticed me to come to Intel. It was a very good decision, even though Hughes was a great company. Anyway, so I was manager of the technology development team in Santa Clara. In 1981, I had a meeting with Andy Grove, and I said, look, I think we need to have some skunk work. Intel at that time was working on bubble memories, magnetic bubble memories, and I said, look, we can do what bubble memories can do, which is replace a disk drive with E2PROM. E2PROM is expensive and it's got all kinds of issues, but it's a semiconductor device, which is what we know. I said, Chuck, let me start a skunk team to develop a solid-state disk based on E2PROM. And he said no. He said no. We don't like skunk teams here. Skunk teams are elite organizations, and we've got 20,000 employees, and we win by everybody working at a little bit above average. Everybody of our competitors is average or below average. That's how we'll win. And I said, every army needs also, special forces. And it didn't work. So that was my first attempt to use non-volatile memory for solid-state disk. In 1983, I found wafer scale integration, and our first business plan was what we call a wafer disk, which was basically to take an entire 4-inch wafer and populate it with E2PROM arrays, and through redundancy and interconnects, basically come up with a whole system. A 4-inch wafer, with those days, 1983, E2PROM would give us a 4 megabyte wafer. 4 megabyte wafer, which of course is one song, one MP3 song. But I couldn't get funding for that, so we changed the business plan, and that was the end of that until I founded SanDisk. Initially it was SUN. My daughter came up with that name, and Sun Microsystem objected, and we had to change our name to SanDisk. So, and I did talk to Gordon also about this idea, and Gordon said, I wish I could join you. He said, I wish I could join you, but what did Andy say? So that was a 30-minute no. Then in 1988, I was basically let go of my first startup. The board picked another CEO, and the next day after I left, I started SanDisk. But the idea was, again, to come back to solid-state disk, mass storage in silicon. By 1988, there was flash memory, which solved a lot of the cost issues with E2PROM. But the approach for that people were developing for flash was very much no flash and very much code store replacement of EEPROM. In code store, you rarely cycle it more than once or twice. You never have to. So the spec was 10,000 cycles, and if you read the fine print, 0.01% of all the bits would fail at 10,000 cycles, which is a complete no-no. Disk drives have 0 error bits, and totally if you're going to replace a disk drive. You can't do this. So my vision was basically to start a company that would develop flash memory that was data flash as opposed to code flash. It would have very high endurance, and it would have very low cost. And part of the ways to get to low cost was multi-level cell. It was an amplification cell, self-amplifying. If you could meter the amount of tunneling of electrons into the floating gate, you could have multiple states, and that would allow you to store more than 1 bit per cell. So this was filed June 8, 1988, 8 days after we started SanDisk. At that time, I was the only full-time employee of SanDisk, but Sanjay Mehrotra and Jack Yuan, my two co-founders, were moonlighting, Sanjay at IDT and Atmel, in fact, working for George. I called George and said, George, I want to make sure you understand what Sanjay is going to be working here is nothing to do with what you want him to work on, but I can't pay his salary. So until I can, are you okay that he moonlights for me? And George said, yeah, no problem. So the idea basically was, in that patent you could see an intelligent programming technique allows each memory cell to store more than the usual 1 bit of information, that is MLC. An intelligent erase algorithm prolongs the useful life of the memory cell, that is reduce stress, erase, and programming to extend from 10,000 cycles to 1,000,000 cycles at the transistor level. But above that, you still needed assist from a system-level solution, and that was really the birth of... Batteries up? And that was the birth of the system flash, which was the missing ingredient to achieve a highly reliable flash solid-state drive. And this was the first patent. This was system flash was developed. The concept was basically Bob Norman, who was our system architect, and he just received just a month ago.
It was the Flash Memory Summit Lifetime Achievement Award.
Yes.
So Eli Harari, Bob Norman, and Sanjay Mehrotra, who's currently CEO of SanDisk, the three of them were the inventors on this. And Bob Norman was the one we honored this year. He was the disk drive guy who brought in the smarts of what a disk drive required and hence how to emulate it with the flash memory.
Right. So I recruited Bob. He was one of the best system architects for controllers for disk drives, but he knew nothing about flash memory, and I knew nothing about about hard disk drives and systems. So we taught each other, and the three of us, Sanjay on the chip design, we developed a completely new chip, flash chip, that for the first time had a sector and header architecture, physical sectors, 512 bytes, and a 64-byte header that was erasable all in one, had the ability to erase in parallel multiple randomly addressed sectors. It had a controller, very, very important, intelligent controller that was a hardware controller, because Intel, Microsoft were working on a software controller, NM systems as well. And actually, when we started, there was no, Intel was still not working on flash file system, but the controller was there in order to make sure that using that header, it knew that header was reserved for the controller to manage the 512-byte of data sector to make sure that it delivered error-free memory. And if a few bits failed, the controller would dynamically map them out. The controller would keep track of every time you erased a sector, so there was a logical hot count for future wear leveling. The error correction, we used the normal error correction, but in addition to that, we used dynamic defect mapping. So as soon as you ran out of spare bits in a sector, you mapped out the sector, and you mapped out an entire quadrant if you had to of a chip. So it's very dynamic, and it stayed there with the controller managing the flash memory through the life of the device, 5 years, 10 years out, which was a very new concept for memory devices, because memory devices DRAM and SRAM didn't have any endurance issue. In flash, it was code flash, it was a non-issue. And data flash was basically, look, if you don't, to guarantee basically a million cycle endurance at the system level, where you have a normal distribution of failed bits. Some would fail under 100 cycles, some would go to 10 to the 7 cycles. The controller would track every bit on the chip. And step voltage programming, parallel programming of many bits with program inhibit, stop stressing any sectors that were already properly programmed, caching for speed, we don't have time, but garbage collection. So it was really a disk drive-like architecture with a disk drive-like controller, but it handled flash memory because we knew what flash required, and the controller guys really didn't know. And the system guys, the host guys that were going to use system flash, knew nothing about flash memory, and to expect them to implement in their TC or whatever, PDA, the Newton or whatever, to expect them to know what they needed to do in order to manage our flash memory it was very clear that it was not possible. So the data header I talked about, we can move on to the next one. The key to the success of System Flash was to get to market quickly, and that meant that we had to be plug compatible with disk drive replacement. It had to be completely transparent. Our device had to be completely transparent, down to the connector, down to every instruction that was a DOS command was translated by a controller into flash memory commands. For example, disk drives don't erase before they write, they overwrite. We had to erase first and then write. And we achieved a 1 million write cycles. So the fight between SanDisk and the rest of the world, which was Intel and Toshiba in those days, was they said, you don't need a hardware controller. Our hardware controller was $70. Software is free. They said, it's an overkill, you don't need it. And I said, no, you need, our customers were telling us, you need to make this endurance issue go away. And the way to do it is through this transparency with a controller. And then reduce the cost through scaling, Moore's law scaling, MLC flash, and the rest is history. So we went through 16 generations. And we were actually scaling faster than Moore's law. But for the first 7 years, we were the only one out there and with that kind of solution. And we were ridiculed by our competitors because our product was much more expensive, but it worked. And it was very fast. eTalks, which was very good for code store, very fast read. XIP, execute in place, 50 nanosecond read. We were a serial memory, very slow read, but very fast write, which is what you need for data store. Basically, we had a solution, total plug-and-play compatible, but all the early adopters, the Go, the EO, the Grid, even the IBM ThinkPad, they didn't have the applications, the apps, and their products went out of business. And we very nearly went out of business. But then the cameras started coming, and then we had compact flash, the digital film card, and eventually we got out of our custom. But it took much longer than I hoped.